How are you doing? Okay, welcome to our today's lesson, and our center of focus in the lesson of today is water and hydrogen. Specifically, the property of hydrogen, and that is reducing property of hydrogen. And from that, I want us to use this diagram to remind ourselves of what we did under that topic. So please write the question, and now we can go through it one by one as we look what is being tested under this topic. So part A of the question that I want you to write there. So students, you can write part A of the question. State two observations that will be made in the above experiment. Write that. State two observations that will be made in the above experiment. State two observations that will be made in the above experiment. Full stop, that is 2 marks. State two observations that will be made in the above experiment. Full stop, that is 2 marks. Then you look at the whiteboard so that you can go through it. So boys, if an examiner asks you to state two observations that will be made in the above experiment, the observations must come from the combustion tube. This one is called combustion tube. Combustion tube. Combustion tube. And what you need to know about this experiment is that you cannot come up with any observation if you don't have any source of heat here. So for you to come up with the two observations, you must include heat in this experiment. And in the combustion tube, two things will be reacting. This one is copper 2 oxide. The chemical formula for copper 2 oxide is CuO. And it will be reacting with hydrogen gas. So this one is hydrogen gas. So to come up with the observations first, you must know how to write the chemical formula. And the chemical formula here in this case will be copper 2 oxide will react with hydrogen to form, this hydrogen will reduce copper 2 oxide. It will take away this oxygen to form copper metal plus water. To form copper metal plus water. Copper 2 oxide is solid, hydrogen is a gas, copper is solid, water is liquid. Then once you have known how to write the equation, you need to know the colors of these given substances formed here. For example, copper 2 oxide is normally black. Copper 2 oxide is normally black, while copper metal is brown. Copper metal is brown. So the first observation, boys, will come up from the color of copper 2 oxide and copper metal. So the first answer for that question is, you say that black copper 2 oxide changes to brown copper metal. The first observation is what? Black copper 2 oxide changes to brown copper metal. Are you together here, boys? Yes. Then the second observation will be, because we are forming water here, this water is liquid. It will be condensing on these cooler parts of this combustion tube. So our second observation will be, there will be formation of a colorless liquid on the cooler parts of the combustion tube. There will be formation of what? Colorless liquid on the cooler parts of the combustion tube. Are you together up there? Yeah. So write those two observations, then you go to the second part of the question. So you need to know those two observations. One, formation of black copper 2 oxide changes to brown copper metal. Then formation of a colorless liquid on the cooler parts of the combustion tube. Are you there, all of us? Yes. Good. Part B of the question. Part B of the question, right? Write the chemical equation that is taking place in the combustion tube. Write the chemical equation that is taking place in the combustion tube. Write the chemical equation that is taking place in the combustion tube. Then the chemical equation already you have it, right? Yes. Are you able to see the chemical equation, boys? Yes. Yeah, here it is. So just copy paste it. That's the chemical equation which is taking place in the combustion tube. That's the chemical equation which is taking place in the combustion tube. Alright, boys, part C of the equation. Part C of the equation, right? Apart from hydrogen hydrogen gas, apart from hydrogen gas, name any other two gases that can be used in the above experiment. Apart from hydrogen gas, name any other two gases that can be used in the above experiment. Then you look at the whiteboard here, that is 2 marks. Apart from hydrogen gas, name any other two gases that can be used in the above experiment. Then look up here, boys. Now, this is how you go about that question. That's a very simple question, would just require your concentration. Now, how will you get those two gases? I want all of us to look here. If you look at this hydrogen gas, in this equation, hydrogen gas has been used as a reducing agent. So, in a nutshell, or in another language, these guys are asking you, name any other gas that can be used as a reducing agent here. In such kind of experiment, other two gases that can be used in this experiment are, the first one is ammonia gas, and another gas that can be used in this experiment is called carbon 2 oxide gas. Carbon 2 oxide gas. Why ammonia gas and carbon 2 oxide gas? All these gases, they possess what is called reduction properties. They possess what is called reduction properties. So all of them, so these ones possess, can be used as reducing agents. So all of them. So give the answer to that question. So the question was, name two other gases that can be used instead of hydrogen gas. So those two gases are written, and you can boys. The first one is which one? The first one is which one, boys? Ammonia gas and carbon 2 oxide gas. Are you together up there? Yes. Next question that you need to understand. That is part B of the question. Part B of the question. Part B of the question. An examiner can ask you or can challenge you in an exam that name the substance being burned at point X. Write that question. Name the substance being burned at point X. Name the substance being burned at point X. That is 1 mark. Name the substance being burned at point X. Boys, look here. I want all of us to look up here. At point X, you can see the flame. At point X here, we have the flame. So, in an exam, if an examiner asks you, what are you burning at point X? The substance which is being burned at point X here is unreacted hydrogen gas. The correct answer there is unreacted hydrogen gas. Unreacted hydrogen gas. Anytime you write hydrogen gas, you'll get 0. Why? Why will you get 0? Because if you say hydrogen gas, it means that all these hydrogen gas, they are not reacting here, but all of them are passing and they are being burnt here. But from the chemistry that you know, the knowledge of chemistry that you gain in Form 1, you should know that whatever is being burnt in point X here is unreacted hydrogen gas. So, have you answered that question? So, the correct answer there is what? Unreacted hydrogen gas. Then the next question that they are going to ask you about this point X is that write the equation taking place at point X. Write that equation. Write that equation. Write the equation taking place at point X. 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 Boys, let us look here. We have seen what is being burned at point X? Hydrogen gas. So if they ask you to write equation, always give your equation, write your equation using chemical symbols, chemical formula. So if hydrogen is being burnt here, this hydrogen is burning in oxygen to form what is called water. So water here is a gas because it's in steam form. Then oxygen is a gas, hydrogen is a gas. And how do we balance this one? By placing 2 here and placing 2 here. So this is the equation taking place at point X. So this one is water. In chemistry, water is also called oxide of hydrogen. Another name of water is called what? Oxide of hydrogen. So water is also called oxide of hydrogen. Oxide of hydrogen. oxide of hydrogen. Right, that one? That's the equation taking place there. I want to understand this thing. They are very simple things that once you understand, you'll never strain when you're in exam. So you're looking at one, boys?
Yes.
Then the next question about the diagram, what they can ask you here, state the observation that will be made at point X. State the observation that will be made at point X. State the observation that will be made at point X. State the observation that will be made at point X. State the observation that will be made at point X. That is 1 mark. Now, at this point X here, look here, boys. When hydrogen gas is burning in oxygen, which observation will you come up with? I want to understand something today, that anytime hydrogen gas is burning in oxygen, it normally burns with a blue flame. It normally burns with a blue flame. So you see, there is formation of a blue flame. There is formation of a blue flame. Formation of a blue flame at point S there. So write that down as the answer. Formation of a blue flame. There is formation of a blue flame. There is formation of a blue flame. The next question that you need to know about this diagram, right? They can ask an exam. State the property of hydrogen gas that was being investigated. State the property of hydrogen gas that was being investigated. State the property of hydrogen gas that was being investigated. State the property of hydrogen gas that was being investigated. Are you able to give that answer? I think you've mentioned that property. Are you able to give? Are you able to give that? Are you able to give that? Answer? Yes. Which property is being investigated? The reduction property. Very right. The reduction property. The reduction property. The reduction property. The reduction property. That is 1 mark in an exams. Are you together here, boys? The next question that you need to understand about these things, somebody can ask you, give the test for hydrogen gas. Write that question. Give the test for hydrogen gas. Give the test for hydrogen gas. Give the test for hydrogen gas. Have you ever encountered that question anywhere?
Yes.
What's the answer for that? Very right. Hydrogen gas extinguishes a burning splint with a pop sound. But some of you normally say that it put off a burning splint with a pop sound. Or some can say it put off a burning splint with a pop sound, still right. It extinguishes a burning splint with a pop sound, very right. But it doesn't burn with a pop sound. Am I clear? Hydrogen gas doesn't burn with a pop sound. But it put off a burning splint with a pop sound. And also it extinguishes a burning splint with a pop sound. Are you together up there? Are you together up there, boys? Yes. Then finally, what you need to know about this diagram, uses of hydrogen. So say, state 2 uses of hydrogen gas. 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 Do you know the use of hydrogen gas, boys? Yes. Somebody tell us. First use of hydrogen gas, yes?
It's used for manufacture of hydrochloric acid.
It's used in large-scale manufacture of hydrochloric acid. Tick. That's the first point. The second one? It is used in hardening. It is used in hardening of oil to fats. Of oil to fats. Through a process called hydrogenation. Through a process called what? It's the same thing that is saying, the margarine thing. Are you getting that? Yes. Then, that one?
It is used together with oxygen to form oxyhydrogen flame that is used in
Very right. It is used together with oxygen to form oxyhydrogen flame, which is used in where? Welding. Which is used in where? Welding. Which is used in welding. Which is used in welding. Now save it. Which is used in welding.